Imagine looking up at the night sky, at all those countless points of light, and knowing that one of the very closest has a planet, a world orbiting around it. There is indeed a strange world very near to us, cosmically speaking. It is a planet that circles the star Proxima Centauri, our nearest stellar neighbor outside of our own solar system. This intriguing world is a mere 4.2 light-years away from us. The star at the center of this system, Proxima Centauri, is nothing like our own sun. It is what astronomers call a red dwarf, a type of star that is far smaller, dimmer, and cooler than the yellow dwarf star that we orbit. Our sun is a brilliant, powerful furnace, but Proxima Centauri is more like a faint celestial ember. Its light is much redder, and it gives off only a tiny fraction of the energy that our sun produces. This has enormous consequences for any planet that might orbit it. A world would need to huddle incredibly close to a red dwarf just to stay warm enough for liquid water to potentially exist on its surface. This proximity creates a very different kind of planetary environment. Because Proxima b orbits so close to its parent star, its year is incredibly short. While Earth takes 365 days to complete one trip around the Sun, Proxima b is thought to complete its orbit in just 11 Earth days. This means that if you could stand on its surface, you would experience a new year every week and a half. The red dwarf sun would hang in the sky, appearing much larger than our sun does to us, but it would cast a dim, perpetual twilight over the landscape. The light would likely be in shades of orange and red, creating a scene that would feel both alien and strangely beautiful, a world bathed in a permanent sunset. This constant, close presence of its star defines everything about the planet. However, life around a red dwarf isn't just about dim light and short years. It also comes with significant dangers. The way scientists found this planet is a remarkable story of patience and precision. They didn't see the planet directly. It is far too small, too dim, too close to its bright star to be photographed with our current technology. Instead, they detected its presence by observing its star, Proxima Centauri, with incredible care. They used powerful telescopes on Earth at the European Southern Observatory in Chile to measure the star's light over a long period. They were looking for something very specific, a tiny rhythmic shift in the starlight. This method, known as the radial velocity method, is one of the most successful techniques for finding exoplanets. It relies on a simple principle of gravity. As a planet orbits its star, its gravitational pull ever so slightly tugs on the star, causing it to wobble back and forth. It's a bit like two dancers spinning around while holding hands. Even the larger dancer moves a little. This stellar wobble is minuscule, almost imperceptible from a distance of over 4 light-years away. For Proxima Centauri, the wobble means the star is moving towards and away from Earth at a speed of about 3 miles per hour, roughly a walking pace. Detecting such a slow, subtle movement from trillions of miles away is an astonishing feat of engineering and a testament to the sensitivity of modern astronomical instruments. The announcement of the discovery came in the year 2016, and it was the result of a dedicated campaign called the Pale Red Dot Project. Scientists meticulously collected data, watching as the spectrum of light from Proxima Centauri shifted periodically. When the star wobbled towards us, its light was compressed slightly, shifting towards the blue end of the spectrum. When it wobbled away, its light was stretched, shifting towards the red end. This repeating pattern of blue shifting and red shifting was the smoking gun. It was the unmistakable signature of an unseen companion, a planet, faithfully circling its star every 11 days. The regularity of the wobble allowed them to calculate the planet's orbital period and make an estimate of its minimum mass. From that tiny wobble in the starlight, a whole new world began to take shape in our imagination. They called it Proxima Centauri b. Based on the data from the star's wobble, scientists have been able to sketch a rough portrait of Proxima Centauri b, though many details remain shrouded in mystery. We know that the planet has a minimum mass of about 1.3 times that of Earth. This strongly suggests that it is a rocky or terrestrial world, Earth, Venus, Mars, rather than a gas giant like Jupiter or Saturn. It's a solid place you could, in theory, stand on. Its size is likely to be very similar to our own planets, making it a true Earth-sized cousin. These characteristics immediately placed it on the list of the most compelling exoplanets ever discovered, as it possesses the fundamental quality of being a solid world in a potentially temperate zone. The planet's orbit is extremely close to its red dwarf star, at a distance of only about 5 million miles. For comparison, Earth orbits the Sun from 93 million miles away. This proximity places Proxima b squarely within its star's habitable zone, which is the region around a star where the temperature could be just right for liquid water to exist on a planet's surface. Because its star is so cool, the habitable zone is much closer in than it is in our solar system. So despite being 20 times closer to its star than Earth is to the Sun, Proxima b might not be a searing, hot inferno. Instead, it could have an average temperature that allows for oceans, rivers, lakes. However, this close orbit likely leads to a strange phenomenon called tidal locking. Just as the Moon is tidally locked to Earth, always showing us the same face, Proxima b is probably tidally locked to its star. This would mean one side of the planet is trapped in permanent daylight, while the other side is locked in an endless, freezing night. If this is the case, the most hospitable regions on the planet might be in the twilight zone, a narrow strip known as the Terminator line, where the sun would hang forever on the horizon. For all that we have managed to deduce about Proxima b, the list of things we do not know is far, far longer. The most crucial and pressing question is whether the planet has an atmosphere. It acts like a blanket, trapping heat and distributing it around the planet, which could prevent the night side from freezing solid and the day side from boiling over. It also provides the necessary pressure to keep water in a liquid state on the surface, and crucially offers a shield against the star's harmful radiation and violent flares. Without an atmosphere, Proxima b would be a dead, airless rock, much like our Moon, and the chances for life would be virtually zero. Directly tied to the question of an atmosphere is the question of water. Is there any on the planet? Even if the temperature is right, you cannot have oceans, lakes, or rivers without the presence of water itself and an atmosphere to keep it from boiling away into space. Was Proxima b formed with water? If so, has it managed to hold on to it over billions of years, despite the relentless battering from stellar flares? It's possible that water exists, but is hidden away as ice on the cold night side or as vapor in a thin atmosphere. The search for the chemical signature of water vapor in the light that passes through Proxima b's atmosphere is a primary goal for future observations. Finding it would be a landmark moment in the study of exoplanets. Of course, the ultimate question is whether there is life on Proxima b. It is important to be clear. We have absolutely no evidence for life there. We are not necessarily looking for intelligent aliens sending signals, but for something far simpler: biosignatures. These are chemical clues in a planet's atmosphere, such as the presence of gases like oxygen, methane, ozone in specific combinations that are difficult to explain through geology alone. The presence of such gases could hint at biological processes, even if it's just microscopic life. The next generation of telescopes, particularly the James Webb Space Telescope, is our best hope. By using incredibly sensitive instruments, the JWST can analyze the starlight that filters through Proxima b's atmosphere as it passes in front of its star. This can reveal which gases are present. In the more distant future, projects like Breakthrough Starshot envision sending fleets of tiny, laser-propelled nanocrafts to the Alpha Centauri system. They could reach it within a few decades and send back the first close-up images of this neighboring world. For now, though, Proxima b remains a beautiful mystery, a close but silent neighbor, inviting us to keep watching, listening, and wondering.